We'll be looking at theorem 2, which states that an angle which an arc subtends at the center of the circle twice that which is subtended at every remaining part of the circumference. Now this is an arc AB. Other arc is from here down to here. It can also be called AB also, but this is called the major arc, while this is minor arc. The angle that this arc subtends is this angle. Then the remaining part of the circumference is the major arc. So if an angle now, maybe we have an angle subtends at this point, at this very point here, it means that this angle twice this angle. How can we prove this? Let's put point C here. I want to go do simple construction. That means we need to, this is center O. Let's join O to C and produce it to any point. Maybe we call it point D. Now, where OA is equal to OB is equal to OC, which is radii. Now let's call this angle, we can call it A1. Then this angle we can call it A2. This angle we can call it B1. Then this angle we can call it B2. Now if you look at this very well, from what we have proved here, this side is equal to this side is equal to this side. The three sides are representing, each of them is representing the radius of the circle, since this is the center of the circle, which means that triangle OAC is an isosceles triangle. Triangle OCB is an isosceles triangle. So these two triangles are equal to each other. So what we want to look at now is, let's call this angle, maybe we call it, this angle we call it M. Then this angle we call it N. Based on our diagram, required to prove, we want to prove that angle AOB is equal to 2 times angle ACB. That is what the law is talking about. That is angle at the center twice angle at the circumference. This is the angle at the center, this is the angle at the circumference. From the diagram we have AOB is equal to AOB. The obtuse of AOB is equal to M plus N. That is this angle plus this angle. Likewise, this angle ACB is equal to A2 plus B2 is equal to A2 plus B2. Now looking at this, A1 is equal to A2. Also, B1 is equal to B2, which means that is base angle isosceles triangle. That is, the base angle of an isosceles triangle are equal to each other. If you proceed, if you look at this angle M representing the exterior angle to this triangle. So we say that M is equal to A1 plus A2, which is exterior angle equals to sum of opposite interior angles. Therefore, since A1 is equal to A2. We can now have our M to be A2 plus A2. So M is equal to 2A2. So let's keep this. This is equation 1. Equation 1. Similarly, in this triangle COB, we see that N is the exterior angle to this triangle. So we have N is equal to B1 plus B2. That is exterior angle equals to the sum of opposite interior angle of the triangle. So we now say, therefore, since B1 is equal to B2, B1 is equal to B2, which is the base angles of this isosceles triangle are the same. So we now have it this way, that N is equal to B2 plus B2. So we have N equals to 2B2. This is equation 2. Now we can proceed from here. We can say, adding equations 1 and 2 together. Adding equations 1 and 2 together. This equation and this equation. That's equation 1 plus equation 2. If you do that, that will be M plus N, M plus N equals 2A2 plus 2B2. That is, if you sum the two equations together. So M plus N is equal to 2 is common. That is A2 plus B2. If you now make a quick recall that AOB is M plus N, ACB is A2 plus B2. So we recall that AOB is equal to M plus N, and angle ACB is equal to A2 plus B2. So what we do now is to substitute into the equation. This in place of this, this in place of this. So we now have M plus N. That will be AOB is equal to these two. This is a 2 here. Multiplied by A2 B2, which is ACB. Proved. So this is how we can prove that the angle at the center twice the angle at the circumference.